Welcome to Klein's Geometry. Today we're going to look at 5-5 indirect proofs, and then we're going to look at triangle inequalities. To write an indirect proof, you're going to do 4 steps. First, you're going to identify the conjecture to be proven. In this case, we're going to look at an obtuse triangle can only have one obtuse angle. The next step is to assume that the opposite is true. So what we'll write, since this says an obtuse triangle can only have one obtuse angle, we'll write an obtuse triangle can have more than one obtuse angle. That would be the negation. Now we just use some direct reasoning to show that that leads to a contradiction. If an obtuse triangle has 2 obtuse angles, their sum is greater than 180 degrees. But the triangle sum theorem says all 3 angles in a triangle must have a sum of 180. So the assumption is false. Just use some direct reasoning and show why it can't possibly be true. And then your last step is just to conclude that since the assumption is false, the original conjecture is true. So we can say, therefore, and a lot of times people writing proofs will put 3 dots like this. That means, therefore, an obtuse triangle can only have one obtuse angle. And that's all there is to writing an indirect proof. You just assume the opposite is true and then do a little reasoning to show that that can't possibly be, and conclude that your original statement was true. So that's all there is to indirect proofs. Now let's look at inequalities in one triangle. And if the theorems that go along with this are the largest angle must be opposite the largest side, and the smallest angle is opposite the smallest side, and vice versa with sides and angles. Now let's look at, before we look at that, let's just look at these 2 paper clips. Now notice, if I push them together, they form an angle right here. And the distance between them would be the side opposite that. Notice as the angle gets smaller, so this is getting smaller, this distance gets smaller also. And likewise, as the angle increases, so does the distance between the 2 endpoints to make that triangle. Now the thing that's important to note here is I can get this all the way across till it makes a straight line here, but then it's not a triangle anymore. So if you added these 2 sums, this sum plus this one, that third side, the distance between these when I make a triangle, has to be smaller than that. But yet I can make it smaller, 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 but notice when the sides come together, there's going to be the difference between the 2 sides. This long side minus the small one, the third side has to be bigger than that, or it won't make a triangle at all. So to figure out how to find that third side, all we're going to do is subtract and add. Now when we're putting them in order from smallest to largest, since the largest angle is opposite the largest side, I want to put them from smallest to largest. So here's what I do. I find the smallest side. It's right here. I cover it up, and what's left is the smallest angle. Angle A is smallest. Then I say, what's the next smallest side? Well, 10.5. I cover it up. There's the next smallest angle. And then I look for the largest side, and that's right here, and I cover it up, and what's left, angle C, is my largest angle. So we might say this angle is less than this angle is less than this angle. When we want to put the sides in order from smallest to largest, I'm going to look for my smallest angle, cover that up, and I see US must be my smallest side. Now I'll go to my next smallest angle, that's going to be 70 degrees, and I'll cover that up, and I'll see GS as my next smallest side. And then I'll look for my largest angle, and that's S, and when I cover that up, I've got GU as my next smallest side. I need the segment symbols over those, and then I might put those in order by saying less than, less than. So that's all there is to that. Now when you want to know if the lengths form a triangle, let's look at lengths 4, 3, and 6. Do they form a triangle? Well, using the paperclip example, we pick any two lengths. So we're going to look at 4 and 3, and we'll subtract them, and we know that that third side's got to be bigger than that, and then we'll add them, and we'll know that the third side's got to be smaller than that. So if we put 6 in as our third side, then we work it out. 4 minus 3 is 1. 4 plus 3 is 7. 6 fits in between. It's less than 7 and more than 1. So the sides form a triangle. You'd say yes. Now let's look at 4, 4, and 8. Pick two of them. 4 minus 4, 4 plus 4. 8, the third side, will go in between. 4 minus 4 is 0. 4 plus 4 is 8. And you see we got a problem, because 8 isn't less than 8. So this is false, and you'd say the sides won't form a triangle. That would give you that straight line. Wouldn't work out at all. Now, one last thing they'll ask you to do in this section is they'll ask you to find the range of possible lengths for the third side of a triangle if you're given two. And you do the same exact thing we just did. You subtract the two you know, and you add the two you know. And the third side has to be in between there. So in this case, if you know 12 and 14, 14 minus 12 is 2. 14 plus 12 is 26. And you know that third side is somewhere between 2 and 26 units long. Okay, that's all there is to it. See it again. If I add 1 1/2 minus 1/4, 1 1/2 plus 1/4, I know my third side has to be between them. So 1 1/2, well, I know 1/2 is the same as 2/4. So 2/4 minus 1/4 is 1/4, so I got 1 and 1/4 here. And 1 1/2 plus 1/4, well, again, I know this is 2/4, so that's 1 and 3/4 here. And my third side has to be between 1 1/4 and 1 3/4. So that's all you have to do. Now, when you look at maps, you can kind of use the same exact process. You might get a location question. Find the range of distances from the library to the bank. Well, if you go from the high school to the library, it's 4 miles. And if you go from the high school to the bank, it's about 7 miles. So what's the possible distances from the library to the bank? Well, all you do is 7 minus 4 and 7 plus 4. And that's going to be our distance. And I'll do 7 minus 4 is 3 miles. And 7 plus 4 is 11 miles. And I know the distance I'm looking for, and I'm just going to call it D, from the library to the bank is between 3 and 11 miles. And that could be, if you subtracted them, if this was your distance to the bank or the library and this was your distance to the bank, and you subtracted these two distances, you can see you'd be at 3 miles. Well, if they were at other ends of town, you'd have your 7 miles to the bank and your 3 miles to the library, and it would be, or 4 miles to the library, and it'd be 11 miles. So that's why we subtract to find the shortest possible distance it could be, here, and we add to find the longest possible distance it could be, here, and we know that the distance is going to be somewhere in between along this scope. So hopefully that's going to help you, and good luck with Lesson 5.5.